Hello everyone, we are going to look through some visualization tools, and I'm going to actually use two applications to show you some of these visualization tools. The first one we're going to use is Jupyter Notebooks, and it's going to be a script called Graphics, and I'm just going to run through some basic graphics stuff. It's kind of at this point when we did R that we looked at graphics. We first loaded a file and played around with the file. We did that using Pandas last time. So this time what we're going to do is we are going to load a couple of other libraries. One is matplotlib, pyplot, and the other one we're going to use is numpy. And then we have a couple other ones we're going to use in the other script. One of them is called Seaborn. I think that's the only other one. And then, of course, we use OS to set our appropriate directory. So in this first script, we're actually not going to load a file, so we don't have to worry about Pandas. Even though I have imported it, I don't know that we really use it much. Probably somewhere along the line we use it. But I'll just show you some basic stuff about how to create a plot. So the first thing we do, of course, is we come up here. And in Jupyter, what you can do is you can put code in chunks. And so each one of these chunks, when you start up Jupyter, if you've got Anaconda Navigator, you can select Jupyter and you just launch Jupyter Notebooks. Each one of these chunks, you can just type in a bunch of code and execute that bunch of code. And then when you save it, it saves the whole lot. It saves all your chunks of code that you've executed. So what you can see here, and if you look through the script, you'll see that I basically started with a very bare-bones script that started out with just naming some variables and setting up a simple plot. And then the next thing I did is I just copied that code into the next section and just added more stuff to it. And I did that repeatedly over and over again. And so what you'll see is a whole lot of replication, but it also allows you to see a whole lot of how we built on the script and got to something that we eventually wanted to get to, which was our first plot right here. Okay. Let's go back to the very beginning then. Okay, so I've already imported my libraries in the first section. I do import matplotlib.pyplot as PLT, so I can use the PLT as the abbreviation, because typing matplotlib.pyplot is a lot to type every time you want to use it, so we use PLT. I did import pandas as PD. I'm not exactly sure, I don't remember if we use it, but I imported it anyway, no harm, no foul. And then I imported numpy as MP. Okay, I typed all three of those in, and then I hit run. And when I do that and hit run, it runs that section of code. Boom. And then it moves on to the next one. Now, if I didn't have anything typed in this one, what it would do is give me a blank section there. And that's fine, and I could just start in by typing in new code. Okay. What I'm going to do instead is I'm going to name some variables. My first variable is going to be x, and x is going to be set equal to a list of 1, 2, 3. So those three numbers. And then I set my variable y equal to a list of 2, 4, and 6, which is basically twice x. Okay. And then I run a simple plot. The PLT is the abbreviation for matplotlib pyplot. So if I wanted to run a matplotlib pyplot plot, then I would type the whole thing in here. But what I'm going to do instead, and this is the advantage of using PLT instead of matplotlib pyplot, is I just do PLT, and you have to put a period, and you have to specify what it is you're going to plot. The default when you type plot is a line chart, and that is what it will do, is it will give you a line chart. It will draw a line between all your pairs of data points, all your coordinates on your graph. If you want to do a scatter plot, then you do plt.scatter, and then the various other forms. Now, what we're using here is something called matplotlib, as I've already indicated, and matplotlib.org will give you all the documentation you could ever want on all the different ways to use matplotlib to create graphics. And so I highly recommend you go over to matplotlib.org and take a look at some of what's available there. So for each one of these, for example, on pyplot, we have, which is part of matplotlib, we have a whole different list of plots that we can run. And it will tell you all the different parameters that you can run with it. So in this case, we're going to run the simplest thing we can possibly run, which is plt plot. So pyplot plot and xy. And then the next thing we're going to do is it's got our plot open for us, and it will allow us to add a title. So again, we're going to use PLT as the abbreviation for matplotlib pyplot. And this time we're going to add a title. And our title is going to be in single quotes. Everything in Python, as you probably have already determined, is in single quotes. So our first plot. Okay. And then we're going to give it some information about that title. We would like to say some font sort of directory or dictation or whatever you want to call this, equals the font name, and then we're going to give it a font font title, actually what it is. So we're setting font name equal to font title, and both of those are in single quotes. So here we have single quote font name, colon, and then the specification, which is Comic Sans MS, which is a type of font that we're using. And then the second thing we do is instead of font name, we set font size. So font size is equal to 20. So that makes the font bigger. Okay. All of that goes into curly brackets. So we were specifying information about the font direction, font name, and font size. We put that all in curly brackets, and then that's all part of the overall command when we're setting our plot title. Okay. So let's go ahead and run that. We'll run the whole thing actually together. And then the next thing we're going to do is we're going to add labels. So PLT, we're going to use the same PLT command. We're going to set an X label value, and we're going to set a Y label value. And those are going to be in single quotes because they're strings. And so we just say X axis and Y axis. Okay. The last thing we're going to do is plot.show. Now, sometimes it's kind of unclear when you need to run this and when you don't. If you're running in a certain editor and you're running code, sometimes what it will do is it will just generate the plot for you in the background and it won't actually show it to you. So that's why you'd use plot show to show whatever's hiding in the background, whatever you've created and you want to actually display. In this particular case, without the plot show, you'll notice that the first plot comes up just fine, and so we don't really even need it. But I've kept it there anyway just to run it. So let's go ahead and run this section of code, and it gives us our first plot. Okay, what do we have here? We have our first plot. It has a font size of 20. It has a font style of Comic Sans MS. So we've got that all set. We've got a X-axis and a Y-axis for our labels. And we've just basically plotted 1, 2, 3. The pair is actually 1, 2, 2, 4, 3, 6. You'll see that they're plotted here. A couple things that are kind of funky, though, that we might not want is that the tick marks that we have on the sides are pretty specific. You've got 1, 1 1/4, 1 1/2, 1 3/4, 2, all the way up to 3. And then here you're going by, well, you're starting at 2 because that's the first starting point. So you'll notice that that's really interesting because the axes sort of accommodated the data. This one started at 1 and went to 3 because we knew we had 1 through 3. This one started at 2 and went to 6 because we had 2 through 6. So the data sort of lived with what it was fed, or the tick marks lived with what it was fed, the data that was fed in, and that's what determined how that was set up. But maybe we want to change some of that. So we're going to move on to the next section of code. And again, I basically went up here to do this. I copied all of this and I pasted it into this section here, and then I made adjustments to it. So first thing we're going to do is a little bit more complex plot. So I'm going to adjust this a little bit because I don't like the way this is laid out. I added 0 to the beginning, and I added 4 to the end. I did the same thing. I added the 0 to the beginning for the Y variable, but in this case I added 8 to the end because it was the next logical number that would come in that series. And I can run my plot now and see what it looks like. But before I do that, I'm going to go ahead and keep the title. The title is our first plot. We've got our font name and font size set. We've got our X-axis and Y-axis. That's all set. But we want to change the tick marks. This is where we're going to adjust the tick marks. So instead of having all this busyness that's going on here, we're going to adjust the tick marks and put in only what it is we want to show. So we'll start at 0 and put everything in, which matches our X-axis. And we'll start at 0 and put everything in, which matches our Y-axis. And we can go ahead and run this. Now when we're ready to run this, as long as we've clicked our cursor in that particular section of code, we hit run, and it gives us our first plot. And that's our first plot down here, with the tick marks set up just as like we wanted them to be, 0 through 10 and 0 through 4. We move on down to the next one, okay? Another cut and paste, but this time I'm going to do some funky stuff to my plot. I'm going to change things up a little bit, okay? So we've got the Y-axis, or I'm sorry, the Y variable is set the same. I still don't like the way that I did this. It's not consistent. I'm going to fix it. This is spaces, and this is being very picky, but I like things to look clean. Okay. We're still going to run a plot. We're still going to keep the same title with the same font and font size. We're still going to have the same axes. Okay. But what we're going to do in this particular case is we're going to fool around with the axes. Okay. Our tick marks on the X-axis are going to be the same as the values in the X variable. But our tick marks on the Y-axis are going to be all the way up to 100. So we'll still have 0, 2, 4, 6, and 8, which are the same values that are in our Y variable. But this time I threw in 100 just to kind of show you what it would do. Let's go ahead and run that. And we see that it does crowd everything down here. And we see our variables are plotted. The X-axis looks the same as it did before, but the Y-axis is looking pretty flat because we threw in 100 up there. And so when we throw in 100, it's going to say, well, nothing reaches 100, but you put 100 in as a tick mark, so we have to account for it. So that's why it looks like it does. But anyway, it just shows you kind of how you can govern or control how the plot looks, basically by specifying the tick marks. Moving on to our next section. This time, what we're going to do is we're going to plot something that looks a little different. Instead of plotting something like throwing in 100, we're going to actually throw in 7.5 and see what it does. And again, it's going to be fairly similar to what we did with 100, only in this particular case, it throws in 7.5, right? The plot accommodates the x values, 0 through 4, accommodates the y values, 0 through 10. We said we wanted a 7.5 tick mark. There it is. And all we did was add that to this PLT yticks there. All right, now we're going to do something that looks a little, let's see, what did we do on this one? Okay, add a label to the initial plot command and see that the plot label 2x has been added. Okay, so what we're going to do here is we're going to add a legend. And up here you see we really haven't done anything, okay? But now we're going to change things up a little bit. What we're going to do when we change things up a little bit is our initial x variable is still set to 0 through 4. Our y variable is still set to 0 through 8. But now what we're going to do is we're going to plot. And we're going to plot x and y, and we're going to label it as 2x. And this is what we're doing. Basically, if x is 0, 2x is 0. If x is 1, 2x is 2. If x is 2, 2x is 4, and etc. and so on. So we're kind of just basically giving it a legend and saying that we want to have a label up there that tells us what this plot really is all about. Everything else is basically the same. Okay, but we'll go ahead and label this, and then we will plot that legend by doing a PLT legend with the open parens. That's all we have to do because we've already set up the label up here. So we go ahead and run this. We get what we asked for. We get 2x as our label up here, and everything is plotted as 2x. Okay. Moving on to the next example, we are going to add in a bunch of options because we're going to change up our plot. Okay. Boy, when I cut and paste this, I made this mistake over and over again. I'm going to fix it every time. Okay. Okay, so x and y variables are the same, but this time we're going to add color, we're going to add line width, we're going to add line style, and we're going to add size markers with colored edges to the plot. Okay, so here's how we do that. The same command is the same. We're still calling it plt.plot. We're calling x and y, but now we're feeding in a whole bunch of stuff. We started already with label, so that's done. We did that in the last section. Now we want to change the color to red. We want the line width to be 2 instead of just 1, so that's a little more bold and we can see it a little better. We want the line style to be, instead of a solid line, it's going to be dashes, so we'll be able to see that. We're going to put a marker there on the points on the line where the coordinates meet. So the 0 and 0, and the 1 and 2, and the 2 and 4, and the 3 and 6, there will be a marker there, and that marker is going to be a dot. Okay? But how big is that dot going to be? If the dot's too small, we won't be able to see it. So we're going to go ahead and say marker size is going to be equal to 20. And that will make our marker bigger. And then we're going to say marker edge color is going to be equal to blue. What does that mean? That means that the marker itself is going to be red because that's what we said the color was going to be. But we want to be able to see it a little better, so we're going to put a blue circle around that red marker. Okay. We'll go ahead and give it the same title with the same font and the same font size. We'll go ahead and give it the same axes. These are our tick marks. That's not changed. And we'll have to plot the legend. Okay. So we go ahead and run this section of code. We get something quite a bit different. Okay. We have a red line that is dashed. We have markers, and the markers are size 20. If you look closely, you can see that there are blue circles around those markers. So we've been able to customize our plot quite a bit. We're going to go in for one more customization on our manual plot. And that is, we're going to actually add a second line. Okay. So we start off, again, with the same variables. And we plot, but this time we're going to actually change something. Because not only do we want it to be kind of more customized and add a second line, but this is kind of small, so we want to make it bigger. So we can do PLT figure, and we can say figure size is equal to 3 inches by 5 inches with a dots per inch equal to 150. So that's going to give us a bigger plot, and we can control that, and we can adjust the dots per inch to be 300. Depends on how precise we want it to be, and we could adjust the fig size to be whatever size we want it to be. This is x by y coordinates. So we already added all these other parameters, this line width, line style, and all that other good stuff, and that's all done. Okay. And what we're going to do now is we're going to set up a plot. And we're going to be, instead of adding all that other funky stuff, and I've actually got that commented out right here. This is the command that we used in the previous section to set all that up, where we set the color, the line width, the line style, and all that other stuff. And if we didn't really need to be that specific, there's a really simple way to get around all this. You can come down here and you can say plot, your x and y coordinates. And in single parens, you can specify your color, you can specify what your markers are going to be, and you can specify your line style just by typing the characters in and enclosed in 2 single quotes. But it's just those 3. Now color is indicated by a single letter, which is R in this case. I've chosen the caret to be the marker, and I've chosen the line style to be dashed. So I put 2 dashes in there, enclose that in single quotes, and then I don't have to type all this stuff. It makes it really easy to get what I want. My label is still set to 2x. Okay, so that'll give me my plot, and that's great. But now we're going to add line number 2. And so x2 is going to be our x2 value. And now we're using NumPy, so we did actually need NumPy. And we're going to set a range. And a range is going to be set 0 to 4.5, and it's going to increment by 0.05. Okay? So that will set up our range, the range that we want, that we're actually going to set up. We're using the NP library, the NumPy library to do that. Okay? So when we do that, then we can say, go ahead and plot line number 2, take x2 and bump it up to its square. And that's basically the double asterisk. What you're doing is you're taking the value in x2 and you're squaring it. Okay? Make it blue. That's the single B. And give it a label. A label, in this case, this is x taken to the 2nd power. Okay? Now what we're doing up here is we're doing x times 2. What we're doing down here is x to the 2nd power. Okay? We're going to start at 0. We're going to go to 4.5, and we're going to increment by 0.5. So remember, when we get to 4.5, that's the one we don't show. The highest value in any array or any range in Python is the one we don't show. So we'll go to 4, basically. The last one we'll see is 4. And so we'll go 0, 0.5, 1, 1.5, 2, 2.5, etc., all the way up to 4. And we'll take that value and we'll square it, and that will be the 2nd coordinate. So the first coordinate will be the original number, and let's just presume that it's 2. And then when we decide that we're going to take the 2nd coordinate, we're going to take 2 squared, which would be 4. Our line is blue, and again, the label we're going to have there is x to the square. So we'll go ahead and add our title. That's the same. Our x-axis and y-axis labels are the same. Our tick marks are the same. Okay? And we're going to go ahead and do the PLT legend. That's going to put our legend up on our graph that we want. That's the same as what we did before. There's one thing that's a little bit different, and that is we're actually going to save. We're going to save our figure. So in this particular case, we use PLT, save fig, and we give it a name. And the name is going to be in single quotes because it's a string, and I put it as a PNG file. And then I also specified dots per inch 300. Remember up here I specified dots per inch was 150. Down here I did dots per inch 300. So I can go ahead and run that. And it gives me my final graph. Our first plot, what do we see here? We have 2 lines. The first line, remember we said we were going to use carets. We're going to use a dashed line, and we're going to make it red. That's what we did up here when we specified these things. Well, where is that? Actually, right here. These things right there. Okay, and we made it 2. This is our 2x line, so we can see that the legend is given us 2x shows us that it's basically plotting 2x. But when we get to the blue line, 0 really doesn't account for much. 1 squared is 1. So it doesn't really account for too much either. We get to 2, we're getting to 4, we get to 3, we're getting to 9, we get to 4, we're getting to 16. So this is our squared plot. We didn't do anything fancy other than call it a blue line, so that's all it really shows us. But it does show us a blue line for our legend, and we're able to see what we have there. So this is pretty basic in the sense that we're just feeding the data in. We specify the x variable and the y variable, and we feed those in. And we don't really do anything fancy with it. And I think it's good for you to learn some of the kind of basics about how NumPy, how Matplotlib PyPlot works. But what we want to do now is we want to look, and I'm going to jump over to Spider actually, to take a look at a plot that looks a little bit more like what we did in R, and that's because it's using the Boston Housing data set. Let's go do that right now. And here it is. I call it housinggraph.py. So let's go through a little bit of what I'm doing. I did a better job of documenting this one, so I think I'm going to, I'll go ahead and post both these scripts. Just remember the first one you're going to have to load up Jupyter Notebooks to look at, and the second one you'll have to look at in Spyder. If I can, I'll save them both into Spyder. I think you can save them both into Spyder. You can just load them up both into Spyder. I don't know that it really matters, actually. Okay, so we got a couple comments in here. We're going to import the libraries we'll need. We are going to need pandas, so we load that in as PD. We're going to need matplotlib pyplot, so we'll load that in as PLT. We're going to need numpy, so we load that in as NP. We also need a new package, a new library called Seaborn, and we're going to use that because we're going to build a heat map. So we're going to import Seaborn as SNS. Okay? And you'll notice if you start working a lot more in Python that every time you load pandas, most people load pandas, they call it PD. They sort of take on a standard alias. And all of these have standard aliases. And so you kind of grow to expect to see what you're expecting to see. When you see a SNS, you know you're talking about Seaborn. When you see NP, you know it's NumPy. So you'll get used to kind of the aliases that are commonly used with these. The last one we're going to use is OS. And OS is what we use to actually set my current working directory. Now, my current working directory, if I were to go ahead and check that, is going to be users CurtD. But my document that I need, and specifically my Boston housing file, is in documents. So I go ahead and import OS, then I do OS change directory, and then I have to specify all of these specific parameters. This is a place where you can really mess things up. But you can go ahead and do single quote because you're doing a string, and it's C:\\\users. In my case, it should be \\\. That's actually an error. Good thing I caught it. And then documents. And documents is closed out then by a single quote and a paren, and the whole thing goes in paren. So that is what I'm going to do to actually get my file, get my directory set. And then the next thing I'll do is I've decided that I want to be able to see all of my data. Now, the data file in this particular case isn't very big. Remember, it's 506 rows of 14 fields. Okay, but the package pandas that we use actually to bring this in, it will truncate. It will truncate what's called abbreviate. So it'll show you like the first 15 rows, and it'll show you the last 15 rows when you want to display the entire set. And it will show you the first, maybe 3 columns and the last 3 columns when you want to display all the columns. And this is a way to get around that. You can, on pandas, PD is pandas, remember we said it, pandas is PD. On pandas, we're going to set options. And the options are going to be just to control the display, and the display is going to be the max rows. So that's basically what this command is doing. It's pandas, options, display, max rows, 999. Well, the data file we're loading is 506 rows, so we're good there. We'll be able to see all the files, all the rows when we want to look at them. It won't abbreviate or truncate any of them. And then the same thing goes for pandas, options, display, max columns. And it's going to be equal to 20, and we only have 14 columns. Unless we add 7 columns, we should be fine. Okay. So the next thing we're going to do is we're going to go ahead and read in our file and save it to a data frame called df. Now, I haven't done any of this. I've just told you about it. But I'm going to go ahead and run it. I can go ahead and click on line number 7. Remember, this symbol right here is the one that runs one line at a time. If you want to run the whole shoot match, you just click on that one right there. But we're going to run this one line at a time just to make sure that everything works right. So we'll go ahead and import pandas, import matplotlib pyplot, import numpy, import Seaborn, and import OS. Okay. The next thing we're going to do is we'll set our current directory. That's set. We'll specify our pandas options. That's done. And we'll read in our file. And now that's done. Okay. Let's make sure our file looks okay. We'll print the first 3 rows. That seems right. Now, if we hadn't set these options, these pandas options, what we'd probably get is crime zone indus, then we get ... and we would get the last 3 fields. That's sometimes very useful, particularly useful when you have 300 columns. But in this particular case, it's just such a small file, we'll go ahead and look on them all. The other thing that we might get, if we did like a whole listing of much more rows, it may give us, like I said, the first 15 rows, and then give us ... in the last 15 rows. But we've gotten around that. So we'll look at the tail. Just another view that the data is there. Okay. Now what we're going to do is we're going to do some plots, and we're going to start with some scatter plots. And we're familiar with this data set because we know it has 14 numerical rows and 14 numerical columns and 506 rows. So the easiest way to do this is to set our variables. And so we're going to set 3 variables. And down here we're going to say x is going to be equal to, now df is our data frame. This is the least descriptive data frame in the universe. And we probably should have called it something else. It was completely up to us what we wanted to call it. We called it df. I would recommend that you not do that. You might call it housing.df like we did in R. You can call it whatever you want. We called it df. But you may forget. And if your script gets more complex and you have multiple data frames loaded, you may not remember what df is. Okay? So be more descriptive than I was in this particular example. But in this particular case, we're going to set the x variable, and you might want to be more descriptive there as well. X, y, z are not very descriptive and not very clear variables. So you could have called this median value, you could have called this room, you could have called it age. But what I do here is I set the x variable equal to, it's the data frame, and where we use the $ and then the field in R, we do a little bit different here. We use square brackets, and we use the field name in single quotes in capital letters, well, in whatever case matches. And in this particular case, they're all in capital letters. So by doing this, I set x equal to a list of 506 median value values. Okay? I do the same thing with y. Y is going to be set equal to the data frame, where we're using the variable of a room, rm. So we'll have, when this is run, y will have 506 values for room in it. And they'll be corresponding, of course, 1 to 1, 2 to 2, 3 to 3 with median value. We do the same thing with z. Z is equal to the data frame, square bracket, single quote, age. And then we're just going to dump in 506 ages for the average age of the houses in the particular neighborhood. Okay. Once we get those set up, then we can start playing around with some of our plots. Let's go ahead and do that. That variable is populated, that variable is populated, and that variable is populated. Okay. All right. Let's build some plots. Now you'll see what I'm doing here. I'm using PLT, so I am using matplotlib pyplot to do my plots. But this time instead of plt.plot, I'm using plt.scatter. Okay. plt.plot is a line plot, but the scatter plot, which you're very familiar with from your study of R, will show you a scatter plot. There it is. Okay. And it shows me what is my scatter plot between median value and room. Now, just like we saw in the previous example, we could set all kinds of labels. We could set all kinds of x-axis, y-axis labels and stuff like that. I'm not going to do that because you've already seen how to do it in the previous section. So I'm just going to go ahead and run through the next one. And the next one's going to be plotting room. No, this was age versus median value. Okay. Now, if we look at these, we can see, okay, the first one looks like there might be somewhat of a correlation. The second one looks like there's not much of a correlation there at all, or if there's any correlation, it's negative. Well, let's find out, okay? So we're going to go ahead and run something called core coefficient. So it's correlation coefficient. It's going to take a look at x versus y, okay? And remember, x versus y, those are still populated. So we have 506 values here for median value, and we have 506 values here for room. And so we'll go ahead and run that correlation, and we'll do it using NP for NumPy. NumPy is the library that gives us core coefficient in order to be able to do this. If you just run npy.corecoefficientxy and you don't embed it in the print command, it won't tell you what the correlation is. So we're going to go ahead and embed it in the print command so it just prints it and shows us directly to the screen. And we find out down here, it's a little clunky the way it looks, but we have a correlation up here of 0.6. Basically 0.7. Okay, it's a pretty good correlation, and it sort of seems to fit the bill. And it makes sense that the median value would be positively correlated with the number of rooms in a house. Okay, well, let's run the next one then. The next one is going to give us a different correlation because we've seen a different plot. It's got a negative 3769 correlation, which is approaching moderate correlation, but it's an opposite correlation, and that makes sense too. The median value would go down when the age goes up. So we would expect to see that. Okay. Well, you know what I want to see is I want to see a heat map. I want to be able to see the whole shoot and match. And I want to be able to see everything that is correlated against each other, just like we did when we were in R. So we come down here and we're going to run another command. And this command, core equals df. This is our data frame dot core. This is a little different from the way we did it in R. In fact, this is actually easier in Python than it is in R. We're just basically saying our data frame, which we should have named something else, .corr, which is take a correlation of everything against everything in that data frame. That's basically what that's saying, and drop it into corr. Again, probably another unfortunately named variable. Then I want you to plot figure, but now before we plot the heat map, I want to set the size. Because if we plot a heat map that looks like these over here, it's not going to be big enough for us to make any heads or tails out of it. So I want to set the figure size to be something that's actually going to be useful. So we'll say plot figure size. This is of course coming from matplotlib pyplot. We're setting the figure size. And then we build the heat map. Now the heat map is a big old long command, and I'll try to go through as much of it as I can. But I want you to pay attention to this in the sense that we are setting a variable AX equal to SNS. SNS is our Seaborn library. And the Seaborn library is the one that gives us the heat map command. So it's the same format that we've seen before. We see Seaborn, basically, heat map. Okay, we're going to be heat mapping using the variable core that we built just up here. The variable minimum is -1. The variable maximum is 1. And the center is 0. And that's all important for when we color the heat map. You know, we want to know what are the extremes and what is the center. So the center may have no color at all, but the extremes may have the boldest colors, just opposite colors. Okay. We have parameters on basically governing how the colors will run. So this is our C map, and then this is a Seaborn diverging palette, and it specifies how the colors are set. I said annotation equals true because I wanted to see the actual labels on the heat map, and square equals true because it's going to put them into squares and it's going to put squares around them. Then it's going to set a tick table, and I'm not going to go into too much detail here. These are just specifications on the heat map. But I think you could, and because this is what I did, I stole this command from something else, you could come in here and you could make changes to this that would govern basically whether you see the annotation, whether you have squares around, maybe the color palette, maybe if you needed to specify the variable minimum, variable maximum, that kind of thing. And then, of course, the variable, the primary thing here is the variable itself, which we set up here. So we could in fact, if we wanted to have a different heat map, we could take a different data set and create and populate core with a different data frame here using the same command, and use the exact same thing to build a heat map that would look similar. It would just have different data in it. So this is definitely a keepable and stealable and slightly adjustable command because it's pretty involved. Okay. Then it will give us our heat map, and then the last thing it will do is we'll go ahead and say we want to save this. We want to save this to mygraph.png, and we'll make the dots per inch 300, and then we'll go ahead and display it. So I think we left off up here where we were about to do core. Let's go ahead and run that. It's set up, so we're good to go. We're moving into our next thing where we're going to say, all right, use matplotlib pyplot figure to set my figure size. That is done. Okay. Now I'm going to build the heat map. Run that, and we've got a microscopic heat map. Okay. But now we're going to go ahead and see. This plot figure didn't look like it worked very well. Does it work for me when I set this up? Okay. Let's try this again. Yeah, it's not giving me what I want, but what I can do then is go see what I actually saved. So mygraph.png, let's see if I can find it. It should be in my documents. Let's see, where did it save it? Might be. Okay, I'm back after a pause in the video because I can't get two things to work. One, I can't get the save figure to work, and I can't get the plot figure to work. So what I'm going to do is I'm going to go ahead and leave you with this video, and I'm going to follow up with a follow-up video when I figure out what's wrong, and submit that as well. This will at least get you a start on this week's assignment, because what I want you to do this week is I want you to go through and I want you to basically follow along, but I want you to change the commands. I want you to, you know, in the first part when you're doing the plot, make the plot numbers different, make the colors different on the plot, make the line or the mark type different or the line type different. You know, just play around with it and see what you can do. And then when you get into the Boston housing data, you can, you know, you can set the variables X, Y, and Z to something other than median, value, room, and age. You can go ahead and play around with some of the correlations. And then what I'd like you to do is go ahead, though, and run through the correlation piece. It's probably from the correlation down to plot figure and then the building of the heat map. The heat map building actually works. It's just it's not usable in the size that it is, and I can't get it to size correctly. So once I figure that out, I'll post a follow-up video to that, but this will at least get you started on stuff that you can play around with, and you'll have 2 videos to watch for this week for Python. Okay, I'll follow up with the second video in just a bit.